Okay, several meetings before we've discussing dynamic block and for each, and we didn't have time to talk in more details about these things back then. And I promised you to give you a separate session regarding, I would say, advanced Terraform things with all these complicated structures. And today, that's the topic for our call. We will go through things like functions, different kinds of functions, for each dynamic block, and different things. So, and basically, I will start with simply showing you a piece of documentation that's like extremely useful and variable. It's called Terraform functions. Over here, you'll have a list of all possible operations that you can do within Terraform, that you can do with variables and locals and other data in your Terraform. This can be, for example, concatenating two arrays. It can be conversion from string to integer. It can be even calculating subnet ID and CIDR. And I will demonstrate several of them. Let's start from the simple one. Let's start with, so how will I do? There will be separate folder, separate repository, or even no repository, just local, without any code, just this function. So, and a single tier file. So let me open my notes 1 second. Yeah, as mentioned, let's start with numeric functions. So first, let's say we have some locals. For example, A equals -5, B equals 10, and C equals 0. So what we can do is really even like that. I will show you this later too. So similar to what we did with, for example, length, we can call a function, pass an input parameter to it, and somehow process and record it to the next, to the further, either to the value of the output or to another local. So ABS, what you guys think it means?
The absolute value.
What exactly the term absolute value means in your description?
So, like for the absolute value is 5, is 5, and the absolute value of -5 is 5 as well.
Mm-hmm.
The absolute value of x is like x if it's called f minus x if x is bigger than.
So yes, totally correct. That's right, and we can validate it using Terraform plan. Yeah, and that's right. A5, 10, B10. It basically, if the number is negative, it switches it to positive. If the number is positive or 0, it doesn't do anything. Okay, couple more examples. Obviously, we can do even easier operations. Let's say we can add numbers between each other, for example, like this. We can subtract numbers, and let's switch the values itself. We can there is a separate function for power, so A will be in the power of B, and even we can even calculate a logarithm. But for some reason, for logarithm, it's doing this weird thing. Looks like it's a bug in Terraform, and no one actually uses it to calculate logarithms too often. That's why it's probably not fixed. That's what I noticed yesterday when I was preparing. And for example, we can also, on top of that, let's say A will be -5, B -10. There is a function called signum that returns 1 if the number is positive and 0 if the number is negative. And let's second be positive so we can see different things. It should be A, and this one should be B. First number positive -1, second number positive 1. So -1 stands for like false, and 1 in this regard in this system stands for true. But we can evaluate these -1 and 1 further and translate it into some other type of action or like information. We can use this as a condition. For example, we can convert this -1 to the text format. So value will be equal. Same situation here. Signum B, but we'll test it using this condition. And what this will mean is that if this expression evaluates to true, like return of signum is equal 1, then the value will be the string, second number is positive. Otherwise, it will return this one, second number is negative. That's how you can transform and manipulate your data even further. For example, API returns true or false, and if the one API returns true, you can query it using data source, and based on result of this data source, you can, for example, either create an instance or not create instance, either take one parameter or take other parameter, and I will show you a little later how it works on practice. Here it is, yeah. Second number is positive. And if we change it to negative, it will be second number is negative. That's for numeric functions. There are significantly more functions, and I encourage you after this session is over to go and play with as many functions as possible. You can calculate maximum, you can calculate minimum, you can round your numbers in different directions, and so on and so forth. Okay, second part that I will show you is couple examples of string functions. Let's say we have a list of like ingredients, and we want to create some dish. Value equals, let me just type it for you, and you'll be able to guess what exactly will be over there. Can you tell me what will be recorded in this output? Like logically thinking.
Each value in the array, like in the ingredients array, with a dash between them. Apple dash peas dash cake.
So what will be the data type of this? Will it be array, several arrays, string? Yes, totally right. Let's try this out. Output. Yeah, exactly right. And let's try basically opposite. Let's say we have some garbage, and it's a string. Cardboard, paper, landfill, and we want to be responsible about our environment and split our garbage and have it separately. Then which function you think, what name of the function you think will be useful for us?
What?
Yes, totally correct. So how both these functions work? So we have a separator. In case of split, it will act as a point that will indicate that that's a separate part. And in case of join, this will be something that you need to add to the final string between the items of the array. This time, yes, we've created an array with 3 items from our string. Okay, let's try another type of functions called file system functions. For example, let's say we have a file. And some contents. And we can read the file using Terraform. And in fact, we already used this function in our user data exercise. Let's try this. And here it is. The content of the file is written to Terraform output. Okay. Same situation with or for example, other variation of this is when we want to read the file in and convert it automatically into base 64 encoding. Some APIs, some cloud, some providers sometimes require base 64 encoded messages. So that's the same message, but in base 64. Okay, and one more latest file function that I will demonstrate to you is a template file. Also very useful, and most likely you will take advantage of it later when you do your own project. Let's say we have some variables defined in our Terraform, and what we can do is let's say we want to generate a YAML file, right? And put these variables into it. Here's how it looks. So we put these placeholders, dollar and a curly bracket, similar to interpolation syntax of Terraform, into this file. And in the code itself, what we'll do is call the type of function, template file, and we are basically instructing that the hostname placeholder will be put here, and port placeholder, this one will go here, right? And let's see what file will we get. Right. So that's basically the rendered YAML file, YAML snippet that we have. And yeah, 1 second. Let me finish this part, and after that, I'll give you opportunity to ask the question. What else can we do? Yeah. So what we can reference, for example, the local directly within the same local block. And let's say we will change this to 8081 so we can notice the difference. Yeah, and now it's taking the value directly from here. So you can manipulate your data in many different ways, and it's should not necessarily be always like a one-liner. You can split it within the same local block and use it effectively. Okay, there was a question, raised hand, please.
Yes. Can we send like an array from the Terraform to the YAML file?
Yes. Technically, we can. It will be slightly more complicated configuration, combination of functions. But overall, I'd say yes.
Okay.
And it will be very good an exercise for you if you would like to try, like practice more if you have free time. So once again, so, and this will be actually a separate Trello card. You need to ideally practice and try this out the same way I showed you, like each and every function that's here in this documentation. Why it is important? Because you'll never know which function and under which circumstances you will need. Like, for example, I don't know, tomorrow there will be some interesting task where you have to manipulate dates. And in advance, you'll remember that there are some functions that allow you to do something similar to that, or very close, or like you'll be able to come up with some recipe with some combination of one function that sends output to another function, and so on. Okay, we've beat this horse enough. Let's move forward with the second topic, is much desired for each block. So let's say our previous example with our VPC. We'll imagine that we have a list of environments. Let's say dev, page, test, prod, and demo, and a VPC. And also we'll declare another variable for our CIDR blocks. And actually, let's have one more option called enable DNS support. So what problem, and that's the question to you guys, what problem with this setup, I'll give a hint, from the readability perspective, do you see with this configuration?
So Terraform true false is -1 and 1.
No, not quite. Not the case. True false is like true false. That Terraform supports Boolean. I mean, what issues with readability, with understanding the code, with understanding what it will create? Try imagine in your mind that you're running Terraform plan. Can you predict what will go where and how difficult it is for you?
I think for like reading the code as it is right now, you will have like to do some mental effort to know that dev has the first CIDR and the first value. You have to follow like each one with the
Yes,
order. It's not grouped together.
totally right. You have to, in your mind, when you're reading this code, you have to match these like values, which one is corresponds to 10.2, right? You need to count 0, 1, 2 and count this again, 0, 1, 2. Totally right. Exactly. And if we have like 100 blocks, it will be like close to impossible. If we have more than 3, like more than several parameters, it is close to impossible. That's the first problem. Regarding second problem, let me quickly create this, and I will demonstrate it to you as well. Okay, good. We've created our VPC. Let's say after that, our management came to us and said, we don't need demo. Please remove it. No worries, we can do this. Terraform apply. One resource to destroy. Everything as we expect, right? Come on, why it takes too long? It's just a VPC, it has nothing. Let me just remove it from Terraform state. It's already should go away. Okay. Let's pretend it never happened. Let's assume that we've deleted everything successfully, and now we have this VPC destroyed. But now let's imagine they say it also, please delete stage. Right? Let's run Terraform apply and see what will happen. So the question to you, why it is suggesting not only that it will destroy one, but also that it will change 2 more resources?
Because the index of the CIDR has changed.
Yes, totally right. And that's the disadvantage of count overall. Ideally, it's better to, like always, when possible, to use for each. And let me demonstrate you how to rewrite the same configuration using for each. So in our locals, we'll have a list of objects that contain each element in this object contains information about one instance of our VPC. And let me copy paste the rest so I don't have to type them from scratch. So first of all, it's significantly more readable because we can quickly find the proper resource and match and immediately see that it has 10.2.0.0/16 as CIDR and DNS support is enabled. Now, how can we iterate through this data structure and create our resources? Using for each, obviously. So it will look something like that. For each equals for item in local.vpc config item.env code item. And let me explain what it means. So basically, we'll create a kind of for loop that accepts this entire data structure. And this is what we mean here, in. So we iterate in these local VPC configs. And for each iteration, each value will be recorded into the item property, into the item object. So on the first iteration, item will contain this. On the second iteration, item will contain this. On the third, this, and respectively until we run out of the objects. Now, what this means, item env code. We need to set the, I would say, unique key that will represent each item in this updated data structure. And we are picking something unique. In our case, this will be env code. And what we are doing further is saying that each object will first have its CIDR block specified, or enable DNS host names support, sorry, of each object will have a value of enable DNS support. And the name of the VPC will be the key of our dictionary that we selected. This means this. Each key. And let's run Terraform apply and see how it works. And if we attempt to delete something from the middle of this list, it will work differently. It will query not by index, but by key. And we simply removing the key from the map, but not the array from the index. And it says exactly as we're expecting, one item to destroy. Let's destroy the rest of infrastructure, and we have two more topics remaining. Any questions regarding for each? Okay, then let's move forward. Let me define the similar construction, but this time it's a map that contains multiple keys, very similar to like security group rules. And what we will do is we will create a VPC and security group in this VPC. And previously, if we wanted multiple security groups, security group rules, we had to manually hardcore or type multiple ingress blocks, right? And also one egress if we wanted egress, right? But instead, what we can do is parameterize these blocks as well. So automatically have it created using so-called dynamic blocks. It also uses for each. So we instructed to iterate it to our list or through our object that we defined here. And the content block will contain the rest of things that usually go to a typical ingress. From port to port to port, protocol, CIDR blocks. And we can reference using the same key, like ingress, and the keyword value. And it will correspond to each item from here. We can have from port, have to port, we can have protocol, and we can have CIDR blocks. And regular egress, just same way as we could type it manually, statically. Let's run Terraform plan. And Terraform will automatically expand this for us deserialize into several ingress blocks. Yeah, here they are. And if we, for example, change this input array and let's say add, or let's say change port. It will highlight that in here. Yeah, just to prove that this is taken from this local. So this allows more complex configuration. For example, when we have, let's say, universal module for a security group, it can accept all rules as variables, and using dynamic block create like any configuration of any security group. Very useful. Yet sometimes it might seem like complicated and difficult to understand. And the last thing, the last trick, and my favorite one that I want to demonstrate to you is condition, equivalent of if-else. I believe no need to explain what if-else is, right? Like regular if-else in any programming language. So just a typical instance with some AMI and instance type in a default VPC, and we can control whether this resource will be created or not based on the value that's set for this variable. And it's very similar to how we translated -1 into text. So it will be count. And if create instance parameter is set to true, then the count will be 1. But otherwise, it will be 0. This essentially means if create instance is true, then 1, otherwise 0, which means like create or not create. And let's run Terraform plan. And it says 0, your infrastructure matches the configuration. And if we move it into true and run Terraform plan again, it will suggest to create an instance. Here's you can do like very complex configurations. Let's say, for example, I don't know, you might want to create Bastion host on dev but not on prod, or maybe that like don't create some type of unnecessary like monitoring external instance or whatever. Like you can create dynamic and complex configurations using all of these blocks. But what I want to notify you about is there should be a balance. Don't overuse this functionality, because otherwise, as Claudia noted, you'll have to spend a lot of mental efforts into reading this code. The code should remain readable. And for today, that's everything that I wanted to demonstrate to you guys. Any questions? Then see you next Tuesday, and thank you for today.
Thank you. Bye-bye.